Hi everyone. So this next section is the first one of our next unit. Our next unit is on similarity. And some kids have said that they learn about similarity in middle school, but I'm not so sure you do anymore. So either way, I'll fully teach it like you've never seen it. So basically what similar figures are in just like regular terms is they're figures that are the same shape, but different sizes. So one could be like a bigger version of the other. So figures that are the same shape but different sizes. So like if you have ever ordered school pictures and you get wallets and an 8x10, let's say, the wallet and the 8x10, the bigger one, are similar. The shape of your face and you look the same, just like one's an enlarged version of the other. So that's what similarity is. There is a symbol for similarity. It's just this, which is kind of like, if you think about the congruent symbol, it's just the top of a congruent symbol. So that means is similar to. And then here's the formal definition of similar figures. So two polygons are similar if and only if their corresponding angles are congruent. So they have to have, all the angles have to be the same. This is why angle didn't work for congruency. Angle is technically, if the angles are the same, the figures are similar in a triangle. Anyway, we'll get to that next time. So it says two polygons are similar if and only if their corresponding angles are congruent and the measures of their corresponding sides are proportional. And so let's talk a little bit about what proportional means. So a proportion, just as a side note, hold on, let me come over here. A proportion is when you have two ratios that are equal to each other. So like something here, something here, something here, something here. It wouldn't be all X's then. I'm just saying like something there. So two ratios set equal to each other. So sides are proportional when their ratios are equal. So basically you'll see in the example, we're going to write ratios for all of the sides and see if they're equal. So underneath proportional, you can just say ratios are equal. That's what it means to be proportional. So there's two things that we're going to be doing in this section. We're going to be given figures, like this first example, and asked to determine if they're similar. And also we will be given similar figures and we'll use those similar figures to find missing parts. So those are the two different things we're going to do. So let's start off with determining if shapes are similar. So the first thing that we're going to do, here's questions to ask yourself, is are all corresponding angles congruent? So you look at the picture and just make sure all the angles match up, and they do. And so if the angles are not congruent, like if you're given it, like if I was given these two figures and none of the angles were marked, I would say that they're not similar because there's not enough information to determine if they're similar. So the angles are important. You have to check the angles first. So once you figure out that the angles are congruent, then you test to see if the sides are proportional. To find out if the sides are proportional, you're going to set up ratios of corresponding sides and simplify. All ratios should be equal if the polygons are similar. So basically, when you set up your ratios, you just have to figure out which sides correspond using the angle markings, just like how we did with congruency. So like 12, for example, would match up with 8, because see how 12 is on a side with 1 arc and 4 arcs, and so is 8. So you basically figure out which ones match and you write ratios of them. It doesn't matter if you put the big figure on the top or the small figure on the top, it doesn't make a difference as long as you do it the same for all of them. So I'm going to go big to small. So I'm going to start off with 12 over 8. There's my first ratio, these two. And I'm going to figure out, is that equal to 18 over, do you guys see how this matches with 12? 18 and 12. Does that equal 15 over 10? Does that equal 6 over 9? Oh, wait a second. I did this on purpose, actually. I tried to make it seem like it was a mistake, but I just couldn't. So I purposely did this. 6/9 is not the correct way to do it. Do you see how for all of these, I had the big one on the top and the small one on the bottom? You have to do that the whole way through. So I would have gotten a no here if I hadn't caught my mistake, which wasn't really a mistake. Anyway, so it really should have been 9/6, big to small. Okay, so, or you could have done small to big for all of them. As long as you do it for all 4 sides, it doesn't make a difference. All right, so now what we have to do is we have to simplify these ratios. So you could simplify them like as fractions, just, you know, how to reduce a fraction. Or if you really wanted to, you can make them decimals. It technically doesn't really matter. So like 12 and 8 are both divisible by 4. So that's going to be 3/2. 18 and 12 are both divisible by 6. Also 3/2. So we're looking good so far. 15/10, also 3/2. You wouldn't want to just like get 3/2 a couple times and stop there. You have to test all 4 of them because like 3 of them could be the same and the last one could be different, but it's not. 9/6 is 3/2. So see how all the ratios are equal. If you had done small to big, you would have gotten 2/3, which is fine too. So we would say, yes, they are similar, because all of the angles are the same, whoops, and all of their sides are proportional. Okay, and then it also asked to write a similarity statement. So we could say polygon or quadrilateral, whatever. Say I did WX, or let's go 1, 2, 3, 4. WZYX. WZYX is similar to polygon PSRQ. The order doesn't really matter as long as you match up the right ones, just like with congruency. Okay, so there's your first example. Here's one more quick one on are they similar. So again, the first thing you want to do is determine if the angles are the same, which notice they only marked 2 pairs of angles in each one. We learned something called third angle theorem in chapter 4 somewhere, where it says if 2 triangles of one triangle are congruent to 2 triangles of the other, their third angles are congruent. So the angles are in fact congruent. Now we just have to set up ratios of the sides. So we went big to small last time, so now I'm going to go small to big. So start with any of them, doesn't matter. 14. 14 corresponds with, so that's on a side with 2 arcs and 3 arcs. So that corresponds with TV here, which is 21. Okay, then we have 1 arc, 2 arc, 16 goes to 24. And then 12 and 18. Notice in all of mine, the bigger numbers on the top. Okay, so now we're going to reduce. 14/21, both divisible by 7, so that's 2/3. 16 and 24, both divisible by 8, also 2/3. 12 and 18, both divisible by 6, 2/3. So those are all the same. So again, yes, they are similar. And so we'll do a congruent statement, or a similarity statement. So let's do triangle ABC is similar to triangle. So I went from 1 to 2 to 3. It's going to be UVT. Those look the same, UVT. Okay, so that's how you determine if polygons are similar. Now on the next page, we're going to talk about how to use similar figures. So the first page was identifying similar figures. Now the second page is using similar figures. Okay, here we go. So if you are given that figures are similar, that means that their sides are proportional, which means ratios of those sides are equal. We just talked about that on the first page. So if we are given a picture with some sides marked and maybe an X and a Y like this one, we can use proportions to figure out what the values are. So you can write proportions. There's also another way to do this using something called scale factor, which some of you may be already thinking about. Like if I told you that these were similar, they have the same scale factor, which I'm now realizing we should define a little bit sooner, but that's okay. We'll save it for those examples. So basically what you would do is you would set up one proportion for each of your missing sides. So see how this, see how we're looking for x here? X corresponds to 13, right? So I'm going to put x over 13 equals, and on the other side of the proportion, I need another pair of corresponding sides. You wouldn't want to use 38 and y. You don't want an x and a y in the same proportion. We don't do systems with proportions. So you want to pick something else. So I'm going to do 32 and 16. And then to solve a proportion, you may or may not remember this from middle school, you do something called cross multiply, where you multiply the numbers that are diagonal from each other. So 16 times x is 16x, and then 13 times 32 is 416. So you multiply the numbers that are diagonal from each other and you set those products equal to each other. So they're called cross products. And then from there, whoops, I didn't have to do that. Then from there, you're just going to solve. So I'm going to just divide by 16. I can tell you right now this answer is going to be 26 without even checking. I don't know why I'm double checking. It is 26, but I knew it was 26 because, so let's write it, x equals 26. I knew it was 26 without dividing it in the calculator because do you guys see how 32 is double 16? So that means x is going to be double 13. Maybe some of you saw that at the beginning. Great. You can use that. It's called using scale factors, which we'll get into in a little bit. So that's how you would do it using a proportion. There are some scenarios where your only option is a proportion. So if that second way with the scale factor seemed easier to you, you do have to know how to do it with proportion too. So let's do the next one. So y corresponds to 38. Now, let me also say that the order that you write these proportions in does not really matter, as long as you're consistent with like going small to big, big to small, like whatever. So see how in the first example, let me use a different color. So x was in the big triangle, 13 was in the small triangle. So I had to do 32 from the big to 16 from the small. So I went big to small. It doesn't matter. I like to always start off my proportion with my variable. So that's why for this one, I'm going small to big, because I like to always have my y, my x, whatever, in the top left if possible. That's just like a preference of mine. So I went from y to 38. So now that's small to big. So now I'm going to go 16 to 32. See how this one is also small to big. So you could really rearrange these numbers in a lot of different ways as long as they're both, why did I put S to M? I think that represents small. S to B, small to big, or big to small, it doesn't matter. So right here we can cross multiply, or notice how 16 is half of 32. So y is going to be half of 38, but let's still cross multiply since we're still reviewing this. So 32 times y is 32y, and then 38 times 16 is 608. And then you would divide 608 by 32, which is going to give you 19. So there's your first example. We'll do two more real quick. Number 4, see my x I'm going to start with in my proportion. X corresponds to 9 based on the markings. Also, I should mention this only works if the figures are similar. So in all these directions, it tells us that the figures are similar, and that's why we're able to write these proportions. Anyway, so we have x and 9. I went small to big, so now I either have to pick 8 or 10 to match up with 12. It's actually 8 that matches with 12, so it's going to be 8 over 12, like so. Again, we're going to cross multiply, so 12 times x, 8 times 9, and then you set those products equal to each other. So it's going to be 12x equals, 12x, why am I just not erasing it? 12x equals 72, divide by 12, so x is 6. Okay, so there's another one. Here's one more. Sometimes you have expressions as a side, so you still just do it the same way. So I'm going to start off with my x plus 1. X plus 1 corresponds to 24. And then I need another pair of sides. How about 12 and 18? So I went small to big, so now I have to go small to big. And then when we cross multiply, I'm multiplying 18 by both of these terms, so you want to put it in parentheses. So I'm going to write it out actually. 18 times x plus 1 equals 24 times 12. So 24 times 12 is going to be 288. So now I'm here. And then we can distribute. And then we're going to solve for x. So I'm just going to subtract 18. Oops. So 288 minus 18 is 270. 270 divided by 18 is 15. So x equals 15. So that's how we use similar figures. Okay. The next part, I'm going to actually define what a scale factor is. I kind of, breezed over it at the beginning. Make a little line here. So scale factor, the definition is just a ratio. So it's a ratio. So a fraction, or technically you could write it as a decimal or a whole number, but usually we write it in ratio form. So a ratio of sides, let's say corresponding sides. Ratio of corresponding sides of similar figures. So only shapes that are similar will have a scale factor. And the scale factor is just like that same ratio that everything reduced to. So just quickly going back to what we did on the first page, determining if these were similar, these would be examples of scale factor. That's that ratio that all the sides reduce to when you write the ratios. So if you're just asked to identify scale factor, it doesn't matter if you go from big figure to small figure or vice versa. But something like this, when you're given that these are similar, and it says find the scale factor from ABC to HGF. So we know that scale factor is a ratio. So since it says from ABC, I don't know if you guys remember writing ratios in middle school, but whatever comes before the 2 goes in the numerator of your ratio. So from ABC to HGF, I'm going to pick any side from ABC. So I don't know, 48. I'm going to match that up with any side from HGF. Well, not any side, the corresponding side. So whichever one the 48 corresponds to, which is going to be 8. Notice that this one doesn't have any angles marked. So if you're ever struggling with figuring out which sides match up, remember we learned about how like biggest sides are across from biggest angles and so on. With something like this, the 2 smaller ones would match up, the 2 bigger ones would match up, and then the 2 middle ones would match up, in case you're wondering. Anyway, so there's my ratio, and then you just reduce it. So 48 divided by 8 is 6. So that would be the scale factor. If I said from HGF to ABC, it would be 1/6 because it would be the opposite. Okay, so basically what this means is if I divide everything from ABC by 6, I'm going to get all the numbers in HGF. Here's another one. So this one wants EFGH to ABCD. So we're going to pick anything from EFGH. How about 7? And then which one does 7 correspond to in the other one? 14. So that means it's a scale factor of 1/2. So everything in this one is half of everything in this one. So that's just your scale factor. Let me erase some of this. Okay. Last thing here. So last thing we're going to talk about is perimeters of similar figures. Perimeter is the sides of a figure added together. So this theorem here talks about how if 2 polygons are similar, then their perimeters are proportional to the scale factor between them, or they're proportional to the sides also. So basically, notice that in this picture, let's see, we have 6, what is this? 6, 3, that's 9, 18, 24. This one, the perimeter is 24 inches. This one, it's 12, 16 inches. So notice if I put 24 over 16, what does that reduce to? 8 goes into both of those, right? So it's going to be 3 over 2. So that was me taking the perimeters and writing a scale factor. You would get the same thing if you did the sides. 6/4 is also 3/2. So see how the sides and the perimeters have the same scale factor. So you can use that to help you find perimeters rather than like finding each individual side. Okay, so given in this last example here, given that these two triangles are similar, it says find the scale factor of ABCD to PQRS, so this to this, and the perimeter of each polygon. So let's see. Oh, this is cut off. I think this is supposed to be 25 if I remember correctly. So one thing I also want to point out is this picture is not marked properly. These sides are marked as congruent, but they're actually not. Like, they're similar. So PQ and SR are not actually congruent to AB and ADC. So I'm going to label them with more tick marks to make it accurate because that bothers me. So we can have 3 and 4 tick marks, but not 1 and 2. Anyway, so this side is 25, this side is 25. This one, we know this is 20, and this is 14. So it says to find the scale factor and also find the perimeter of each polygon. Well, we can find the perimeter of ABCD pretty easily, right? Just add these sides together. So 20 and 20 is 40 plus 28. So the perimeter of this one is 68 units. This one, we can't find the perimeter of right now because we don't know all the sides. You could find QR and PS and then add them all together. Or I'm going to show you how you can use the perimeter in a proportion with your sides. So I'm going to say the perimeter of that one is X. And notice that we do have one pair of corresponding sides, 20 and 25. And we have perimeter and perimeter. So see how I have 1, 2, 3, 4 things to use in a proportion? So let's do it. So basically, it doesn't matter what you put first. I'm going to put X first because that's just my preference. So X represents the perimeter of the big figure. So I'm going to go perimeter of big figure to perimeter of small figure equals side of big figure over side of small figure. You could also do, I'm not going to write all these out, but to talk it out, you could also do perimeter of big to side of big equals perimeter of small to side of small. That would be another option. You just can't like crisscross when you do it. Okay, so anyway, here is my proportion, and now let's solve it. So we're going to cross multiply. So 20 times X is 20X. 68 times 25 is 1,700. And then 1,700 divided by 20 is 85. So that means the perimeter, so 85 units, because this is perimeter. So this is the perimeter of PQRS. And then if we wanted a scale factor, you could take either 68 and 85 and reduce it, or it's probably a little bit easier to reduce 20 and 25. And it wants ABCD to PQRS. So I'm going to take ABCD 20 and put it over 25. These are both divisible by 5, so let's reduce it. So that's going to be 4/5. So that would be the scale factor from ABCD to PQRS. So that was a lot. I get it. But all pretty easy concepts once you try it. So please let me know. Don't hesitate to ask. Come for ACLAB if you end up having any questions about this. And then next week after your test, or before your test, I guess, depending on, well, who's watching this. Most likely A through L is watching this, right? So your test will be on Tuesday, and then you'll do this, more of this on Wednesday. All right, so that's it. You have a great day. And again, let me know if you have any questions at all.